Welcome to my TikTok. Have you guys ever using ChatGPT to help you do stuff that can save you a lot of time and increase your performance on your research?
A little bit.
So like that's the power of AI, because AI can help you increase the efficiency and save you times to do stuff. And ChatGPT is one of the application here is called the language understanding, which is like understand what you type into the bar to like ask ChatGPT to help you do stuff. And here's a graph of how AI is improving over time. As you can see, they put the score, which 0 means like the human's performance. Why we were not using AI, and as you can see, the time before 2015, image recognition, speech recognition, and handwriting recognition is slowly improving until this point, and they can do much better than humans. And that brings to my research question: what are the primary different structures using machine learning, and the idea of the applying math algorithm, and what are the best applications of each structure? Now let's talk about what's machine learning. Machine learning is a subset of AI, and that will give the computer the ability to run without human interaction. And deep learning is a subset of machine learning that uses neural network to learn, which is like a copy from like a human brain, which I will talk about later in the presentation. And the difference between deep learning and machine learning are: machine learning, you need to have certain knowledge in certain field. If you, for example, if you want to predict a stock market, you need to have knowledge in business or economic in order to write up a machine learning model to help you predict the market. But in deep learning, you only need to know how to build up a neural network model to help you do the prediction. And here's the process of machine learning, which is you need to collect raw data, put your data into structure, put that in an algorithm, then you will have a model, improve your model. At the end, you will have a golden model. That's the same idea how you write out your senior thesis. You take your research, organize your research, and write it up. You have a rough draft, refine it based on your feedback, and have a final draft. And there's three kinds of structure in machine learning: unsupervised learning, supervised learning, and reinforcement learning. So for supervised learning, one of the tools they use is called classification. In order to use supervised learning, you need to have labeled data. So for example, if you look at the image here, you have all the apples and strawberry mixed up, but the apple is labeled as apple and the strawberry is labeled as strawberry. So you put that in the algorithm, they will classify, like group all the apple and strawberry together. Here's one of the algorithms they use to do classification. It's called subtractive machine. The idea of this is you have a line that divides two different sets of data, and you only looking at the closest data to the line. So, and you try to have a largest margin as possible by adjust the line like to the next to point. The point here is called the support vectors, and the idea of this is trying to get the largest margin. The reason for this is if you have a biggest margin, you will have a clear separate between two different data, so you have more clear to see how each data is separate. And here's one of the applications called text classification, which you have a mixed text file, and you try to group all the similar topics together, which is in this case is technology, sport, and fashion. So because of the big margin, there will be a big difference between these three topics: technology, sport, and fashion. So they will clearly separate like different topic ideas. And here's one of the another classification models called the k-nearest neighbor. The idea of this is to, if you want, for example, if you want to predict what kind of person you are looking at all these people around you. So this model, we are looking at your friend and your family. So what did your friend play any kind of sport? What kind of sport did they play? What kind of food did you eat? And then we'll try to do a prediction based on the people next to you. And here's the math. The math is kind of easy. It's just like solving for the hypotenuse for a triangle, which is a squared plus b squared equals c squared. So like c is the hypotenuse, so you try to like square root all this information. But in this case, there will be like many a's and b's, so that will be many dimensions. So like it's like not only two things. Like it can be sport, food, or like drinks you like to drinks or something. So, and here's an example. Predict, is John gonna get a loan for his car? So first they were looking to pick the people that are next to John. So like which one is the closest to the least closest? Then they will do the math here. So the number 15 and 15 here is the distance between you and the person you want to predict and yourself. So you can get the distance between that. So for example, if you taken the age, so John's age minus George's age, and plus John's income minus his income, plus the number of credit card minus his number of credit cards, so you will get the distance. So that will shows you how close you are with this person. So in this case, like your firm is close to 15, so you take the average of this. So yes and no is like yes, you get along, and like this person is no, so he didn't get along. This person is yes, so he get along, and this person is yes too. So like they take it all the average, come for John to predict like he will get along for his car. And here's another algorithm they're using. It's called a random forest. So before talking about forest, talk about trees first. So like the idea of that is you start with the root and you go down to the leaf. So basically you have a large question, and you break up the question into a little question in order to help you get a better prediction. So for example, if you want to ask is a person fit, you will look at the age. Is the age younger than 30? If it's yes, you look at did the person eat a lot of pizza? If it's yes, it's like means unfit. If it's no, means like fit. And if the person is older than 30, then you look at like how much exercise you do. If he do exercise, that is considered a fit person. If it's not, then that's considered an unfit person. So the idea of the random forest is you take all the decision tree, put into a group, taking the average of all the decision tree to get you a better prediction. Another thing that supervised learning can do is regression, which is a line of best fit of all the data that gives you a number to do your prediction. For example, if you want to predict a person's income, the dependent variable will be the amount of money you make, and the independent will be the age you are. So, for example, if you are 15 years old, then your income will be lower based on all this blue dot. All this blue dot is all the data that you collect from other people that's been labeled how much income they make in a certain age. So if you want to predict a person is 15 years old, you will look at this line and have a prediction on the income. And here's the most famous application for supervised learning. It's called image regression. So for the model, you have all the data labeled. So for a car, you label your data what a car looks like on on your model and what the person looks like on your model and the objects. So as you do the prediction, the model will search for all these type of different objects to make a prediction of, oh yeah, that's a car and that's a person. And next structure is unsupervised learning, which is different from supervised learning because they use unlabeled data. So they are trying to organize all the data based on the similarities. So they will put all the similar shape and color together. The algorithm they use is called K-means cluster, which is just group all the data together based on the similarities. So like for example, if you are a tall person, they will group all the tall person together, and if you are a little shorter person, they will group all the same type of person together. And here's the type application for unsupervised learning, which is anomaly detection. The idea of this is to cluster all the similar data together, and anything that is outside of the group, which is considered anomaly. So when you look at here, it's looking at how much amount of the person is spending each time. So as you can see on the graph here, 200 is like the person is spending less than $200 every time. But in here, the amount of money is increased. So like the computer have the knowledge to know like there's something wrong here. So there's a possibility that the person is the credit card got stolen or got used by got stolen by another people. And the last structure is called reinforcement learning, which is you have an agent, an environment. The agent is gonna do an action in the environment in order to get a score. What the state is what the state means is how many times the agent is going to the environment in order to get the highest reward as possible. And there's two types of policy in reinforcement. One is called off policy, one is called on policy. The SARSA, which means state action, reward state action. So and that's the on policy reinforcement learning. What the on policy reinforcement learning is, you have a certain rule you need to do in the environment in order to get the reward. So the agent need to follow the rules. So if you do something wrong, just go, didn't get any reward and try to do it again to get the reward. And here's a type of policy, it's called Q-learning, which there's not a certain environment, like there's no rule in the environment. As long as you get the reward, you will get to the goal. So for example, if the person is trying to get to the goal, if the person goes left, you will get a negative reward. If it goes down, you will get a negative reward as well because the person is far away from the goal. So if it goes up or goes right, it's like a step closer to the goal. So that will get a reward, and the agent can remember what the reward you get from the last state. So what state means is like last try you go to the environment. So they will have to create a table for themselves to remember what step is the best to go through. And as I've been saying, like the application for reinforcement learning is self-driving car. I think that is one of the applications that is for in this type of machine learning, because the certain rule you cannot break while you are making this self-driving car model. For example, if there's car next to you, you will not like just turn and hit the car. So like there's will be a rule that can stuck the car in. And the main difference between these two types of reinforcement learning is this one is a more safe way to make a model to train, and this one is like a way that a model can do anything else, but like this one have a high risk, so it's like more dangerous if you put that in a self-driving car. And in this case, the car is the agent, and the role and the car next to them is the environment. So as the agent goes through the environment, is trying to like see if the car is allowed to speed up or to make a turn based on the environment. Like, is there any car like next to you or not? And that is a example of the Q-learning, reinforcement learning, because each time you move a piece is in a new environment, so you don't have a certain rule. You can move any piece you want, but if the move is not that perfect, they can go back to the best reward they have and try to like make a better move. And like now let's talk about neural network. Neural network is a structure based on the human brain. The idea of this is to take in all the neurons on the human brain to list them all together in the neural network. And what each of the dot means is just an equation for how do you calculate the output. So, for example, if you want to predict a human face image, you will like input the image, and they will do the calculation based on the hidden layer and give you output of the calculation they will do is to check if there's a nose on the image, eye on the image, ear on the image, a mouth on the image, and they will give you a prediction on like yes, that is the image, or no, that's not the image. And here's a deep neural network. So the idea of this is you can break up many hidden layers you want. So the model can get the most accurate prediction based on like as much as calculation you do, and how neural network can apply to each of the structure for reinforcement learning. So for reinforcement learning, it's called deep Q-learning, which before Q-learning is just a table that remember what you did in the previous state. But like for now, that's the agent. That's a memory of the agent. But for now, the agent is the neural network. So it's trying to give you an idea, and that is the type of structure that you see in supervised learning is the convolutional neural network, which is do image recognition. So it's taking a little part of the image for each of the input layer.
Hey Kai, can I interrupt you? How many more slides do you have? We're at 18 minutes right now, so
it's one more slide.
One more slide. Okay.
So it's taking like a little part of the image for each of these dots and separate them for as many dots as possible, and put that in a hidden layer to give a prediction of a percent chance of what number is that, and that is a application for unsupervised learning, which is organized which is self-organized too. So it's organized all the data you have. Like that's the same idea of unsupervised learning, just organize all the data you have. So in conclusion, as we discover like all the different type of structure, we can apply all this structure into many different other kind of fields, such as travel, business decision making, AI in insurance, sales and marketing, healthcare, farming, and making tools, and that's it.
On your camera? Yeah, if you guys could take, I'm just gonna mess with this instead.
Let's start questions while
Yep.
Lily's gone. Since